Hello my dear students, this is Akash HD. Welcome to the ASD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn the derivation of displacement in n second of motion. After that we will see Galileo's law of odd numbers, very important, and we will solve questions also that is came in a NEET JEE exam. Okay, so let's start the video. So here you can see the topic is displacement in n second of motion. So see here, let an object starts with initial velocity u at t equal to 0 and moves with a uniform acceleration a for time n as shown in diagram. Why I am telling here uniform acceleration? Because equations of motion that we are going to use, that is applicable only for the uniform acceleration. Okay, so what is happening that here? Let's see here. Here let's take here, this is the initial point, the t equal to 0, not the time is t equal to 0, and let's take here x equal to 0 is there. Okay, and from here the object is going to start with initial velocity u. Okay, and anyhow during the complete motion, what is this? The acceleration is this, but the acceleration is the uniform. That means equal change of velocity in a equal interval of time. Now after that, what is happening that here? The object is going to travel for how much time? N seconds. Okay, so let's take here, this is t equal to 0, and after that let's take here, this is t equal to 1 now. Then let's take here t equal to 2 now, 0 to 1, 1 to 2, then 2 to 3, 3 to 4, 5 to 6, like this now. So here I have taken here, let's take here t equal to n. So before that, what will come here? It will come here t equal to n minus 1, is it? And let me write here the some alphabets for the better understanding. A, B, C. Now you can use D, E, F, G number of things. So A, B, C, and here I have taken here M and N. Okay. So here we have to understand what is the meaning of the nth second of motion. So let's understand the basic. If I talk about here first second, what I am telling that here, if I am telling here first second. So first second means where to where? 0 to 1. That means we can tell here t equal to 0 to 1, will call here the first second. Similarly, if we talk about here second, what I am telling here that here second. So here what will become that? Remember that t equal to 1 to 2, is it? If I talk about here third second, so what is the third second? Third second means, now you can guess, t equal to 2 to 3, is it? So first second means 0 to 1, second means 1 to 2, third second means t equal to 2 to t equal to 3. So similarly, if we talk about here nth second means here the displacement of the object in nth second. That means where to where? Guess please. T equal to n minus 1 to t equal to n, is it? What I am writing here? T equal to n minus 1 to t equal to n. That is called what? Nth second. Okay. So in this nth second, displacement of the object can be calculated as. Okay, so nth second means which point to which point? From point M to point N here, is it? So Mn means what we can write here? Kindly see very well. Mn means An minus Am. What is this? An minus Am, is it? So if I write here, see, this Mn is given by what? An minus Am. Okay, and this Mn is only called displacement in nth second of motion. And I hope so you know very well, when the object is traveling in a straight line without changing direction, then displacement and distance both are equal. Interchangeably we can use it, not a problem. Okay, so Sn equal to, we can write here An minus Am. An means how much time? A to n means n seconds, and A to m means how much seconds? N minus 1 seconds. Okay, so here I can use equation of motion, you know, ut plus half at square. So An means n seconds, so I can write here un plus half An square, is it? Minus, after that Am is for how much time? N minus 1 second. That means u n minus 1 plus half a n minus 1 whole square. Okay, now physics completed, we have to simplify this here. So here un plus half an square now will multiply this now. So this will become un minus u. So after simplification, minus un plus u minus half a n minus 1 whole square, is it? And what are the things will cancel out? This un and this un has cancelled. I will write here u plus half a, and I can write here what? N square minus n minus 1 whole square. Okay, even you can open this with the a square minus b square formula also, not a big problem. So here u plus half a square minus b square means in one bracket a plus b, in one bracket a minus b. So if in one bracket a plus b, I can write as c n plus n minus 1, is it? N plus n minus 1, okay. And let me write here, this is the medium bracket here, like this here, okay. And after that, what this will become here? Another one we can write here, see, another one. A plus b, a minus b, so n minus 1, and here like this here, okay. So I hope so this is very, very clear. This is a, this is b, that means a plus b, this is a, this is b, that means a minus b, okay. And after that we'll just simplify this, so it will become here, see, u plus half a, n plus n minus 1 means 2n minus 1. Now this will become here what here? 2n minus 1. Similarly here n minus n plus 1, it will just become here 1. Okay. So anyhow, what formula we have got here? We have got here, you can see very well, Sn equal to u plus half a 2n minus 1. Is it? That is what we can write here. See, displacement in n second means what? U plus half a 2n minus 1. Now this is the formula, kindly remember that, very, very important. Okay. Actually Sn is the displacement, but if the object is traveling in a straight line without changing direction, so displacement we can use as a distance also, not a problem. Okay. Now let's see the question. The question is important. See, an object starts from rest and moves with a uniform acceleration. The ratio of displacement traveled by the object in 5th second, so n to nth second is how much here? Okay. So what is the formula here? Formula we know very well. Sn equal to u plus half a 2n minus 1, is it? And the object is starting from the rest. Starting from the rest means u how much here? 0. Okay, that means we can write here Sn equal to half a 2n minus 1. Now this is the formula. And now they are asking for which time to which time ratio. We have to see here. They are asking 5th second to nth second, is it? So according to the question, if I write here S5 by S9, S5 by S9, so anyhow I can write here, see, half a 5. That means now we have to put n5. So 2 into 5, that means 10 minus 1. Similarly here also half a, now and we have to put 9. So 2 into 9 minus 1, that means what is coming here? 18 minus 1. Then what we can tell here, what are the things will cancel? This half a and half a is cancelled. That means 10 minus 1 means 9 and 18 minus 1 means 17, is it? So answer is coming what here? 9 by 17, is it? That means correct option is here. Option C is the answer. Okay, great. So after that we'll see. Now from here question used to come a lot. The Galileo's law of odd numbers. Odd numbers you know very well, like 1, 3, 5, 7, like this. Based upon that you will see the final expression. So see here, let an object starts from rest and moves with a uniform acceleration a for time n as shown in diagram. Now that we have seen it already. Now ratio of displacement in first, second, third, fourth, fifth, like that and so on, n second can be calculated as here. Okay, so first we'll write here, before calculating the ratio, we'll write here this thing here. S1 will come what here? Tell me please. S1 means, you know the formula. What is the formula? The formula I will write here, see, Sn equal to u plus half a 2n minus 1. Now this is the formula. This is the formula. Okay. Now starting from the rest means here, starting from the rest means u anyhow how much here? 0. That means if I write for the first second here. Okay. So what this will become here? For the first second. Now for the first second it will become here u n value will be 1. Now and u value will be how much here? U value will be 0, is it? So we can write as 0 plus half a 2 into 1 minus 1, is it? That means we can tell here S1 will come here half a into 1, is it? Similarly, if I write for the second, that means t equal to 1 to t equal to 2, what will become here? 0 plus half a here 2 into 2 minus 1. That means what this will come here? See, S2 equal to half a, and here 4 minus 1, that means it will become here 3, is it? So you can see S1 is coming here half a into 1. S2 is coming here how much here? Half a into 3, is it? Similarly, if I write one more for you, if I write here the S3 how much here? See, 0 plus half a, and it will come here 2 into 3 minus 1, is it? That means it will come here S3 equal to half a, and 3 into 2, 6 minus 1 means 5 here, is it? So like this here we can tell here the fourth second also in the same way now. And if I write for the n seconds, what will come here? See, 0 plus half a, and it will come here what here? 2n minus 1, is it? Now after that, you know S1, S2, S3 and all you know now. So here if I write here the S1, S2, S3 and so on Sn. So what this will come here? See, half a 1 is 2, half a 3 is 2, half a 5 is 2, dot dot dot, and here half a 2n minus 1, is it? I hope so this is very very clear, is it? So here this is the is to sign is there, is it? Don't mix up. No. So what will happen? All the places half a all will cancel out. That means we can write here finally S1, S2, S3, dot dot dot, Sn. What will come here? 1 is 2, 3 is 2, 5, dot 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 is 2, 2n minus 1 here, is it? 2n minus 1. So here let me write here now. This one 1 is to 3 is to 5, and here like this is this here, is it? Like this here. Now, so students, I hope so this is very very clear to you. Galileo's law of odd numbers here. S1 is to S2 is to 3. How much here? You can see very well. 1 is to 3 is to 5 is to 2n minus 1 here. Okay. But the question arises, in which situation we can use this Galileo's law of odd numbers. So see here please. Essential conditions. First one, either initial velocity or final velocity v should be 0. Okay. If in case what is that happening? The speed of the object is increasing. Okay. So in that situation, it should start from the rest, is it? Like when we are dropping any object, na, that time it will start from the rest and the speed will increase. Second thing, if what is happening, speed of the object is decreasing and at the end it is going to be stopped. Example, when we are throwing any object, so that time what will happen that here, when it will go up, velocity or speed we can tell it will decrease, and at the highest point it will become 0. So the condition is that either u should be 0 or v should be 0. Okay, here what will happen that here, this speed should be increasing, correct na? Then only initial velocity is 0 and it will keep on increasing. Here what will happen that here, speed is decreasing and finally it will stop here. Okay. Second condition, very very important, acceleration should be constant. That means which kind of motion, uniform. We can tell uniform acceleration, otherwise all these things will fail. Uniform acceleration. And third one, the time interval should be same. What should be same? The time interval should be same. Why? Because first second means time interval 1 second, 0 to 1. Second means time interval 1 second, 2 to 3. Third mistake happened. 1 second means 0 to 1, 2 second means 1 to 2, 3 second means 2 to 3, 4 second means 3 to 4. So here what is there? The time interval fixed 1 second. So just like that, time interval can be fixed 2 second, 3 second, 4 second, that we are going to see here. But remember that here the time interval should be same. So if these three conditions are satisfied, we can use the Galileo's law of odd numbers. So let's see here the question. No? Then only we can understand furthermore. So see, the question is the ratio of the distance traversed in successive intervals of time by a body falling from rest R. So this is the motion under gravity when the object is falling. Okay. So when the object is dropped, u equal to 0, first condition is satisfied. Acceleration 9.8 meter per second. This is also one constant value depending on the sign convention. It may be plus, minus also, not a big problem. We will see detail later. Okay. So u is 0, acceleration is the constant, time interval, t is also constant because they are telling that here equal interval of time here. Is it? So see here, successive intervals of time. Na? So see here. So if all these three conditions are satisfied, they are asking here the ratio of the distances. Three conditions satisfied, that means correct option is here, option A. Even no need to draw here the diagram also here. Is it correct? Let's see here this question. A particle starts moving from rest, see, moving from rest with a uniform acceleration. It travels a distance x in first 2 seconds and the distance y in next 2 seconds. Then which option is correct here? Okay, so again let me satisfy here the situation. So u is given here, how much here? 0, first condition satisfied. Second thing, acceleration is constant as they have given in a question, second condition also satisfied. Third condition, first time interval, how much is this? First 2 seconds. Again next 2 seconds. That means what is this? The time interval delta t is how much? 2 seconds. That is also constant. Now 2 seconds, 2 seconds, 2 seconds, 2 seconds. Like this it is going here. Okay. So what will happen that here? If I just write here the diagram. No? So if you will see the diagram here, no, diagrams here. No? Started with the rest u equal to 0, time t equal to 0. And let's take what is this? The time t equal to 1. So you know what will happen that here? In this, if it is traveling how much here? X. Is it? So what will happen that when you will go for the 2 seconds, no? So this is the 2. So when you will go for the next 2 seconds, that means t equal to 4. First 2 seconds, 0 to 2. Next 2 seconds, 2 to 4. So you know here what will be this? You know very well it will come here the 3x. What will come? Odd numbers. 1 is to 3 is to 5 and all that. So what will come here? It will come here the 3x provided it is moving with a uniform acceleration. Okay. So in the question they only told that here this is y. So what is the y? Y is given here y equal to 3x. Three conditions satisfied here. By the diagram also you can see very well y equal to 3x. Is it? Next one see here. A body starts, anyhow starting only, a body starts from rest and moves with a constant acceleration for 2 seconds. It travels a distance x1 in a first half of time and x2 in the next half of time. Then how much here? Again same story. Let me see here the conditions. Initial speed is 0. Is it? Acceleration, what is this? The acceleration is here, students, constant, and the time interval. Time interval, how much is this? See, total time is t. First half of time, t by 2. Next half of time, t by 2. That means delta t is how much here? Always t by 2. T by 2. That is, this time interval is always fixed here. Na? So these conditions are satisfied. So first t by 2, x1. Next t by 2, how much here? 3x1. And that 3x1 is only x2. So what will come here in the same way? The x2 will come here, 3x1 here. Okay. First t by 2, x1. Next t by 2, 3x1. And that is only x2. Na? Next one see here. NEET 2023 question. Even no need to draw the diagram also. Directly we can see here. See. A stone falls freely under gravity. It covers distances h1, h2 and h3 in first 5 seconds, next 5 seconds and the next 5 seconds respectively. The relation between h1, h2 and h3 how much here? Okay. So when the object is dropped, u how much here? 0. Dropped acceleration moving under the gravity depending on the sign convention plus minus 9.8 meter per second square. Most of the time when it will fall I will take here plus. Okay. And the time interval how much is this? 5 seconds. How can we tell here? See, initially it is going t equal to 0 to 5. In this how much here going? h1. After that what they are telling that here? Next 5 seconds. That means 5 to 10. How much is going here? h2. Then it is going here 10 to 15. Next 5 seconds. So again what is given here? h3. So you can see very well here. Here the time interval is also fixed here. 5 seconds, 5 seconds, 5 seconds. Is it? So in this situation, what can I write here? Anyhow, the odd numbers. h1 is to h2 is to h3. How much here? 1 is to 3 is to 5. Is it? And when I will just simplify one by one, see, I can write here h1 by h2 means 1 by 3. h1 how much here? h1 by h2 means 1 by 3 here. Okay, that means from here h1 how much here? h1 I can write here h2 by 3. Similarly, if I write here the h2 by h3, na, or okay, depending upon the options here. If I write here the h1 by h3, so h1 by h3 how much here? 1 by 5. Is it? So what is the h1? h1 how much here? h3 by 5. Is it? So h1 h2 by 3, h1 h3 by 5. Which option is correct here? You can see very well. The correct option is here. Option B is the answer here. Is it? Galileo's law of odd numbers. Without drawing the diagram even we are doing here. Now see the next one. Second last question. See, a particle starts its motion from rest under the action of a constant force if the distance covered in first 10 seconds in s1 and that covered in the first 20 seconds is h2, then how much here? Okay, so again let me see here the situation. It starts from the rest, u equal to 0. Now, constant force means F equal to ma, A equal to F by m. If force constant, acceleration is also constant, uniform acceleration. But here, how can you see that here whether time interval is constant or not? Time interval delta t. Okay. When you will check it very properly, first 10 seconds S1 and for 20 seconds S2. So see here I will see here, I will show you the time interval is constant, 10 seconds and 10 seconds. I can take it very easily. How can I take it here? See, This is the situation, is it? So if I write here, see here, starting from rest, u equal to 0, time t equal to 0, moving with a uniform acceleration here. So what will happen that here, 10 seconds, t equal to 10 seconds, what it is traveling here, s1, is it? And after that here, 20 seconds, what is traveling here? What it is traveling here? It is traveling here, s2, is it? Now after that, you know very well here, this one how much here, 0 to 10, 10 seconds, s1, again 10 second to 20 second, how much here, again time interval 10 second, that means here what will be this here, this will be 3s1, is it? So you can see very well, s2 means s1 plus 3s1, s1 plus 3s1, how much here, 4s1 here. So what is the correct option? The correct option is here, s2 equal to 4s1, option B is there. Now second last question, see the question is what, see, a small toy starts moving from the position of rest under a constant acceleration. If it travels a distance of 10 meter in t seconds, the distance traveled by the toy in the next t seconds, how much here, is it? So here again what is given here, u is 0 starting from the rest, acceleration is a constant, is it? And the time intervals here, first they are telling that here t seconds, again next t seconds, that means that this delta t is given t and that is the constant, is it? So if I write here the first t seconds means t equal to 0 to t, no? T equal to 0 to t, what is given here, let's take here, this is x1 is given here, how much here, 10 meter, is it? So if you will go for the next one, let's take here t equal to t to 2t, is it? Next t seconds they are telling that here. So what you can tell here, if this is the 10 meter, next one what is this, a 10 meter, next one 1:3, na? So 30 meter is this, and remember that here this one just represents time, na? Time 0 to t, time t to 2t, so 30 meter is where, option C. If they ask even further next t seconds like a 2t to 3t, then it will become how much here, guess, 50 meter, is it? Now the last question asked in a JEE 2021, question is looking big but very easy. See here, water drops are falling from a nozzle of a shower onto the floor from a height of 9.8 meter. The drops fall at a regular interval of time. When the first drop strikes the floor, at that instant, the third drop begins to fall. Locate the position of second drop from the floor when the first drop strikes the ground here. Okay, drops starting from the rest, u equal to 0. Now, motion under gravity, a is constant, plus minus 9.8 meter per second square. Delta t, they are telling equal time interval, that means delta t is also constant here. Now, this thing is known. Now, after that, if I draw here the diagram here, so see, this is the diagram here, is it? Here somewhere one tap is this, now this is the tap is this, no, tap is there, okay. So here what is happening, that the drops are falling. So what will happen, let's take this is the drop and this is the drop here. Now this is the which drop, first drop, now somewhere here second drop, and here third drop is there here, okay. So what they are telling that here, when the first drop hits the ground, the third drop is just going to fall. So remember that here also, see here please, this all these three conditions satisfied now. So here also what is this, Galileo's law of odd numbers. This one I will take here x. So automatically this will become how much here, tell me, 3x. Speed is increasing here, okay. That means total how much here, can you tell me here? The total is 4x, and distance how much is given here, 9.8 meters. So you know very well 4x is a 9.8 meter, okay. So hence the distance of the second drop from the ground here. Now so see a second drop from ground, now second drop from ground, how much, tell me? It will come here 3x, so 3 into x value from here, how much here, you can write here 9.8 by 4, is it? No? Because 4x equal to 9.8, so x how much here, see 9.8 by 4 this is. So 3 into 9.8 by 4, when you will simplify this, it will come here 7.35 meters. So which option is correct here? The correct option is here, option D. Is it, students? So I hope so. This video based upon the Galileo's law of odd numbers, you have understood very well. Keep studying, keep growing.